Very good afternoon, all. I'm sure now all of you are motivated enough to start doing programming and have started practicing in a good way. In the class I have seen today, most of you doing very well, and some of you have been probably uncomfortable. So we will be definitely able to improve further. If you keep on practicing, definitely you will be doing much better. So let's resume from where we stopped yesterday. And we have talked of polynomial addition, and exponent-based representation coding is what we discussed last time. So based on the exponent, yesterday we have written some partial code and I asked you to complete. I'm sure most of you have done that. And primarily, if you remember, we have decided here to have some loop, and inside of this we wanted some comparison to be done, and we discussed that some poly1 I dot exponent to be compared with poly2 exponent, and we briefly discussed that we can simply say take some ijk variables and then have similarly for the other case for less than case and other case for the equality case, and then accordingly we can write the code. And the loop should be when till the both lists are non-empty. So how to have that? What should be the loop? Probably now you have understood that I need a while loop because I don't know how many times I am going to repeat. So both lists non-empty means if I am using I variable, so I can be taken as less than n1. And similarly, I can take j as less than n2. So that will mean both I and j are within the range, and accordingly they will be taken. So obviously I have to do I equal to 0, j equal to 0, and similarly k I can take for the poly k, and accordingly some I plus plus j plus plus k plus plus etc. to be done, and remaining terms to be copied here. For the convenience of those who have not done good programming or who are uncomfortable, I'll show the sample solution. But I expect most of you to complete this coding based on what we discussed in the last class. So let me just go to the dev CPP and demonstrate you some of the simple coding for that. So now you can easily see here, first thing, read first polynomial. So this is a simple logic. Almost same logic to be repeated for the polynomial 2. I can read number of terms, and based on number of terms, my exponent and coefficient to be read. How to declare a corresponding array of polynomial or array of structures. This is there. Type def, I already discussed last time. So type def struct. Normally, we can write here the word poly if needed. Even if in this case I don't write, still it will work. But for linked list, etc., that will be needed. Otherwise, this becomes the data type for future. So this becomes a data type, and now I have poly A, B, C. Accordingly, first polynomial read, then I have second polynomial read, and now my logic starts. And again, initialization, it is always advisable to keep the initialization always just before where it is needed, so that you never forget to do this thing. See, some of you probably might have a habit to do during the declaration of the variable. Yes, that also can work perfectly fine, but sometimes you forget that. So it's always good that you make a habit in your programming that I will be always putting it at just where it is needed. And again, I have put here semicolon. Although comma will also work, but probably some of you might not be aware what is a comma as an operator. So safely, I have 3 different statements with a semicolon, and that is a better way of programming and easy way of programming. Condition, obviously, I going from 0 to n1 minus 1 because total n1 terms are there, meaning they are stored in the array 0 to n1 minus 1. In poly B, the second polynomial is stored from 0 to n2 minus 1, so j will vary from there. So we will every time compare the exponents. If first exponent is less, that means poly B term to be copied. So this can be one way of copying. Other way of copying can be that you can also write dot exponent to be explicitly copied from the other terms explicitly as an exponent. And so that also can be one way of doing. And if you are copying the exponent, then similarly, you have to also copy the corresponding coefficient. So there is nothing wrong if you write like this also, and here you write it as coefficient, and here also you write coefficient. So this way also you can do, but this is also in structures, it is allowed that full structure can be copied from one to other directly also. So both syntax are okay. Else, if they are equal, the coefficient will be definitely added. So here you can't write poly ck equal to poly ai plus poly bj. No, there, because only coefficient is to be added, but exponent is to be as it is copied. And moreover, polynomial, two structures cannot be directly added automatically, nothing will happen. They can be only assigned. So one structure can be assigned to another structure, but for adding various members, you have to explicitly write this statement. So those who have never used, for them, just remember this and it will work. And in this case, I++, J++, K++, all three needed. Then I say, now I need to go for comparison. Now I say, I need to find whether how many terms are remaining. So I said, if I less than n1 means there are some terms remaining which have been not been used or copied or added in poly A. I have already written a command that this is not needed actually. Why not needed? Because when I write the same condition effectively here, if is effectively unnecessary. This condition will automatically check the same. Even if I don't write if, automatically this while will check that. And while I otherwise also I need, because whatever terms are remaining, I have to repeatedly copy all terms from poly A into poly C. So that I need. Similarly, if there are some terms remaining into, because I don't know whether they are remaining into poly A or into poly B. So this could be there. Ideally, I could remove this. In the other case, I have not written that condition. So if there are, if let's say poly A was consumed totally and poly B was having some remaining terms, then this while loop will work. So at most one of these two while will work. In some cases, both while will be totally false and nothing will happen. I keep on adding, then I say I must generate n3. So n3 will be generated from here. And I am saying n3 equal to k because k here is incremented later, but n3 tells the total number of terms. If k becomes a 5 after addition and now I come out, effectively k5 means in poly C, the values were stored from 0 to 4 and k is a 5. But 0 to 4 actually means there are total 5 terms which have been generated. So n3 is actually 5 and the values available are 0 to n3 total, 0 to n3 minus 1. Now here I am printing also in a smarter way that although you could directly print the exponents and coefficient as a pair also, but probably I am showing the data in a more useful manner where I'm showing the data something written as 5x cap or power 80 plus 3x power 70 minus 5x 50. And last term should have no plus printed after this, because after having every term, I'm writing here plus. And then, so I wrote here less than n3 minus 1, and final term for the I being n3 minus 1 equal to that. In that case, the final term will also be printed. It will be more clear if I show it through a certain example. So if I am giving this input and I try to run this value, let me just have this. Yeah, so let me execute it. Yeah, so here I give those inputs. I can directly, of course, when I type everything, it will work, but I have just copy paste the data. Now, what is more important to see here is how output is being displayed. So n3 minus 1, total terms are n3. Out of those n3 minus 1 terms, 0 to n3 minus 2 terms are printed using this symbol plus 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 up to this. So using for loop, I'm able to print this much, and then final term I print like this. So this is how I'm showing the in output. Of course, you can still further improve, because if you see carefully, here plus is also printed and minus is also printed. So probably I can even make more logic and correct all this. But again, that's all just extension of the programming features. More core programming of the addition has been done. So of course, our main focus is always addition of two polynomials, and that logic should work well. Having said that, let me now stop this and come back and resume from here. So just for your convenience now, the addition logic, easy logic, I have already demonstrated. Then I asked you yesterday, that can you think of any exceptional or special condition? Yes, I'm sure some of you have the answer. So answer is simple. Like if I have some term 3x raised to 50, say earlier there was x raised to 80 plus this. This side I have, let's say, x raised to 60 minus 3x raised to 50. So this term will cancel. But in my current logic, this term will be stored with coefficient 0. And ideally, it should not be stored. So if after addition, coefficient is becoming 0, this term should not be saved. This term will never exist. This improvement should be done in my code. Even if you couldn't do it, fine. Even if you couldn't think, fine. But yes, this is one of those cases which I should ultimately, as a good program, I should aim to always understand and do that. So that is what we will be always targeting now. Where to do? In the coding where? So now you can easily think where. I'm sure you know this is the case when exponents were equal. So equality case was where I was talking. Say poly 1i or poly ai dot I dot exponent, similarly poly 2 or j, poly 2 or b, whatever you say. In this, we have to make some provisions of this situation. Having knowing this, now today we will be spending more time in understanding the modularity also and how to make a good quality program from the same. So how to decide module? I always said reusable, independent, and doing one unit of work. In this problem, which modules I should have? So let's think. Of course, now I say what I did earlier was that my main 4 steps were read first polynomial, read second polynomial, then I said add 2 polynomials to generate a third polynomial, and then I said display the result, or to be precise, display third polynomial. This is what logic we made. So primarily we had 4 steps, macro steps. Now, probably some of you could think that during addition itself, I could have probably done the display, because one of that, what was the need to have a poly 3? I might not have stored poly 3 at all, directly displayed. But from modularity or from good programming viewpoint, that was always needed. And in modularity also, that will be helpful, that first this step will get completed, and then next step will have a separate module. So I should have stored. I should not unnecessarily club these 2 steps into same step, and that will be again not a good way. Secondly, let's say I wanted to add 4 polynomials. Say I wanted to write my program which should add 4 polynomials. Now, either one way could be that I should write another program where I will be adding or 4 polynomials, comparing and all that. Instead of 4, if I wanted, let's say, 6 polynomials, 10 polynomials to be added. Now that becomes a problem. So if I'm writing modules, maybe I can say using step 3, you did this. This becomes a poly, let's say, poly 5, or let's say it becomes a poly 5. Then you could say poly 5 plus poly 6, poly 3, again using step 3, and this leads to, let's say, poly 6. Then you could say poly 6 plus poly 4, again using the same step 3, and then you are able to generate poly 7. And poly 7 is nothing but equivalent to another addition. Or you could have also done poly 1 plus poly 2 through one particular addition of two polynomials. Similarly, poly 3 plus poly 4 added through another polynomial addition of 2. Whatever result, this gave another poly. This also gave another poly. And now these two also to be added using the same addition of two polynomials. So now you can appreciate the advantage of storing the result, not directly displaying. So not directly displaying has been quite advantageous to me in this particular case. And from modularity viewpoint also, that is very useful. So now understanding how should I make module. Reading one polynomial has a certain number of 4, 5, 6 lines code, but almost same code just with different variables is to be done here. And I have to rewrite that. If the same code with different variable is needed, obviously that could be much more easier to write one function and the same work achieved. So now I can easily see this can be one function, and the same function can be used to read another polynomial. So I can say read poly ideally can be one function, one module. Similarly, add to poly, maybe I can think of having add poly as another module. And similarly, display poly can be another module. And all of these modules should be reusable, and they will be definitely useful also. Even display module can be useful because through display module, I can display not only poly 3, but maybe if I want to just ensure that I have read correctly poly 1, I can use display poly to display poly 1 also, or maybe poly 2 also. And of course, if any other final result, that also can be printed. But the same module is reusable and can be used. So ideally now in this situation, I can see my whole program in main should have 3 modules used where read poly will be called twice. So step 1 and 2 will be done via this. Step 3 will be done via this, and step 4 via this. And of course, code can be extended further to add more than 2 polynomials also just by calling the functions again and again. So that's the whole advantage of functional programming or modular programming. Knowing this, let's try to see how to make modules. So I want to make a read poly module. Then simply saying making a module word is not sufficient. Function will be made this, but its parameters are to be decided. Its return type also to be decided. How should I decide that? What should be the way to find out this? So the rule is treat that this is one unit of work done by one particular person. Say you have given this work to some human being also. You ask him, read a polynomial. Now, whatever data this module needs from outside is its input parameters. Whatever it will do inside for any function, it will be the inside logic. Whatever generated results are coming from this, they will become output parameters or return type. To be precise, it will be more clear if I say I want to add 2 polynomials. So if this work is given to someone as a function, as a method, that you have to add two polynomials, then if you ask someone, okay, add two polynomials, the obvious question from the other person is going to be, tell what is the value for the first polynomial, what are the values for the second polynomial. So that is what it requires input. For doing this work, the person needs first polynomial. Person also needs second polynomial. For first polynomial also, what if you say, okay, I have this array. He says, how many elements are in this array? That also should be known. So first polynomial effectively means n1 and poly1 array. This is what is the first polynomial in totality. Second polynomial means n2 and poly2 array. So all this should be supplied to this function if this function needs to work. Similarly, what this will do, this generates a third polynomial. It need not be displayed or printf only. Third polynomial gets generated. So third polynomial is the generated or output of this function. Output doesn't mean display only. Output means this function has generated output or results through this. So the results of this process or function are as output parameters. So third polynomial is output. Effectively, it means n3 and poly3. So ideally, I need for this input parameters, which are going to be definitely poly1 and first polynomial and second polynomial. For function which was named as add two polynomials. And output parameters are, of course, in this case, third polynomial or result generated. So this is how I decide. So everything of this will become through your parameters, and output can come through return type to the function. Yeah, parameters for the function. So whatever parameters I need, I will decide based on that. Now talking of read poly. So read poly obviously is a different kind of a function where value will be read from the user, because that is also sometimes to be done. But like if I'm saying partial addition, later it might not be read every time. I am adding 5 polynomials, first 2 added, then addition of this particular to be done with the third. One of the polynomial was to be read, second was partially generated previously. So, but if I want to read, obviously inside scanf will be there. Inside of this function, the scanf, etc. will be there. Then question is, what this function should be supplied from outside or by the main. If there is something like this, by the calling function. If there is something which this function needs, that will become input parameters. And in this case, I can easily see, I will ask the user only via scanf that how many terms are there, what are the exponent coefficients. Means calling function need not supply anything. I will do everything inside read poly. So effectively, input parameters are not here at all. Then what do we mean by output parameters or return type? That is simple, that what result is being generated by this function. Same should be returned back and should be sent back to the calling function. To the calling function. What is a calling function? In this case, main probably, but it could be something else also. In this case, for our case, it was main init for the time being. Now I can see read poly will actually, the polynomial which has been read should be returned back, because that will be needed to be passed as input for add poly. So that polynomial should be returned. Total number of terms which were read, that will also be needed by the main, etc. So both of this should be the parameters for output. Now, one good thing is that some integers or some char, float, etc., they, if parameters, they can be used only as input parameters. And the reason for that is they are passed as call by value. Hence, the number of terms related cannot be a parameter, because it cannot be used to return a value. It can be used to supply a value. For the time being, it can't be a parameter. Of course, through pointers, it will be possible. Without that, no. So it cannot be a call by value parameter, to be precise. But good part is arrays can be automatically, without any problem, used for input as well as output parameters. So my work becomes simple. Hence, I can say now, my logic can be simple, that for a read poly, my polynomial which is being read can be returned or can be as output via parameters, and a number of terms can be via return type. Return type can be only one, so I have no choice. So I can easily think that I should do int read poly and then whatever parameters needed. Input parameters are nil, so I can directly have the poly or poly term. Well, while making the code yesterday, we wrote word poly term, and whichever poly I want to read, their name could be poly 1, poly 2, poly 3, poly A, whatever. Whatever name you use here, same name is to be used inside the code. And the size here, let's say if I have declared 50, then I should write here 50. I might not write also, but if I'm writing, the size must be same as given in the actual used variable, as given for actual variable which will be passed. Which actual variable? For example, in main, you will have calling of a read poly. Say you will write here read poly 1. Then this, whatever is the variable size for poly 1 declared as array size, the same must be there. And that effectively means anytime you are going to use all parameters size of array must be 50 if you are writing here 50. If it is variable, maybe probably you can skip to write, but that will be true only if it was 1D array. In detail, we will talk later. But by writing this, as soon as I wrote int, it means I'm going to have a return type. What value? Maybe total number of terms read. So that will definitely mean my last statement must be returning an integer. So I must take some variable, let's say named as n, and the same is being returned. Rest logic can be now read your polynomial and store into the variable POLY somewhere. And that will be automatically returning to call this. So effectively, my call is going to be something like this. Second time call is going to be n2 equal to read poly 2. So through this, I will be able to read both polynomials just by calling the function again. Again, note down, in the call, there is a semicolon. So when you have a function call, effectively only variable names, no data type, and a semicolon also at the last. Then we call it as a function declaration, or I'll say function definition first. Function definition meant something like int, read, poly, something written here, and the code for the function also written. This is called function definition. In this, the data type will also be must, variable name, whatever you give along with square brackets, etc. must, and no semicolon at the last. So this line is your function definition. Return type is mentioned, function name, function for each variable, the corresponding data type, variable name, any simple name. It need not be same as what is original variable. You can have any simple name, any name which is different or same as other names. Any one you can take. Square brackets, if size also needed, at least for one-dimensional size is not compulsory, 1D array is not compulsory, 2D array we will talk later, and if the code is written. There is another concept of saying function declaration or prototype. Function declaration or prototype is also used in some situations. In programming, it might not be compulsory, but sometimes it may be needed. It will be written something like this itself, polyterm, etc., and everything written, but with a semicolon. So function declaration versus function definition will differ in terms of a semicolon. In definition, no semicolon will happen to come. And in case of function declaration, semicolon will be present. And it will mean code will not be written here for this function. Code not immediately in the next line. Of course, one line answer I will give why we need function declaration or prototype is, if I write a function after its call, function declaration and prototype is useful. If I am defining the function before its call, then function declaration prototype is not compulsory. Not going beyond that, those who want to study more, they should read the book and understand it more from a C programming book. Coming back to addition logic. So we have already discussed this one. Now I need add poly function to be done. So what should be the parameters for add poly? So we have already said I need poly1, and poly1 actually meant the corresponding n1 to be supplied. Along with that, poly1 array will also be needed. Of course, if I am talking of a syntax, I'll say syntax I'll talk later. But if I have add poly, so my parameters are n1, then your poly1 array, which is to be added, then n2, then your poly2 array. Both are needed to be supplied. And from here, poly3 array will be generated and n3 will be generated. And similarly, I can think of having a display poly. Display poly will require only inputs, and output is directly displayed on the screen. So no output parameters will be needed for the display poly. Having said that, let's see the similar solution, which I'm going to show you through DevCpp, and a better code I'll demonstrate to you. So here, yes. Okay. So now you can say this is a good code or a better code, where I have given here function declarations, because main is here and functions are defined below. Had I defined the functions above, the production prototype was not needed. Now you can see read poly. So polynomial being supplied to it, number of parameters. If I read this in the main, then this should become parameter. If I want n also to be read by this function inside, then n could be by return type int. So here in main, what I have done, read n1 inside main. You have a choice to decide, but if you have read inside main, then n1 needs to be told to read poly, and poly a will be output parameter. And because there is no int type, so I will not write n1. Alternatively, this call could have been definitely n1 equal to read poly a also. So this also could have been one way of doing this. Similarly, I say, now I have made a polynomial display function also, so I'm able to display whatever I read. Then I say read a second polynomial, and after that, again, I can have a display of a second polynomial. Later, I will say now, I will call poly3 to be generated via polyadd. So I made a polyadd function. First polynomial passed, second polynomial passed, third polynomial being generated as output or result. So this is also parameter. N1 being supplied, N2 being supplied, and N3 being generated by return type. N3 I cannot pass here directly, as call by value doesn't work. As we have written, simple data types require something special. So for the time being, we are avoiding pointer syntax. So I will not talk of that. This becomes a fairly simple job. Now you can see how to write function. So read poly, void, because n is being supplied, not being read by this function and being returned. So this way here, I have a read user n, and then poly a. So if I write here poly a, I will use a throughout here poly a, poly a. But during a call, it can be replaced by second time with poly b. So first time, read poly will work with poly a. Second time, if it is passed parameter as poly b, automatically it will read poly b for the reading value. Now, based on that, I have done this poly reading, etc., etc. So read poly will be called. Then comes add poly. More or less, whatever logic you have written earlier, same logic, everything, just by giving this extra function definition, rest everything is more or less same. All logic being what we have already written. So whatever logic we read, just copy paste here, it becomes your function. Nothing special to be done. Here I have also added a new condition to handle that special situation. I say if a coefficient is coming as a 0, I'll not increment k, that is it. And I will not store exponent. So I say simply I++ and j++ means coefficients cancelled, and that term from poly A or poly B both have been consumed. So increment I and j. But this term is actually not effectively equivalent to storing into poly C, because k will remain at the same value. Next time, whatever result will come, that will be writing onto this same poly C. So just by avoiding that, I'm doing that. Of course, there can be many other ways, but by this, I'm saying that actually, if the terms cancelled, k is not incremented, term is not stored. Initially, it was temporarily stored into poly C k dot coefficient, but because k is not incremented, next time, whenever we come, again, poly C k dot coefficient will be calculated and the same value will be overwritten. If, let's say, this was the last term and cancelled, once I come out, k is always 1 plus the last index where value is stored. Still, it will be fine, and this value will be ignored, and my total number of terms will be k minus 1. As I said, my total number of terms will be, actually total number of terms are 0 to k minus 1. So total terms are already same. 0 to k minus 1, that will be n3. So the way we did. And now this condition, as I already said, that this is actually not needed. So I can safely remove this here and keep it like this. As soon as I do this, I should make sure that my indentation is recorrected so that I don't unnecessarily leave the unindented code. So this becomes a better code where modularity has been taken care, plus the special condition has been taken care. Poly display, more or less whatever logic we have written there. So here that is one good way of doing programming. Of course, there can be still better programs. So it's not that it is always the best. You can still improve it. But I'm not saying that this is not good or this cannot be further improved. Yes, you can think of doing that. For example, how? For example, in your display, what you have done is I'm getting something like, let's say 3x raised to 80 plus minus 5x raised to 70. So if you see plus is also printed, minus is also printed. Improve it. That if next value is negative, I should not display I should not type the plus at all or print the plus itself. One of the symbols. If the next value is a positive, maybe only then you need to do that. So, but it's optional. So I'm saying all this is optional because our focus is not display, not reading. Focus is addition, operation which we are targeting. That is our focus. So this must be done. But for better programming, you should think of doing this. Not only that, I will say, can you think of having display to be more even good earlier? Now what we have written, exactly like this, can you display? Effectively means at present what you wrote was 3x cap 80 minus maybe 5x cap 70, but they are in the same line. Can you think of displaying it 3x 80 comes above? So on your screen, you manage your screen in a way that you calculate where 80 should be displayed because this line will be printed first. So you have done some mathematical calculations, printed 80, let's say if this is 1, 2, so you have left 2 blank spaces and then printed 80. Then you have next value 5x, then this 70 plus 36x 60 and so and so. So in between, accordingly, you have to put blanks by calculating based on all this. This itself requires a lot of logic to be made. But that will mean effectively your first line will be printed to print exponents with the spaces. And next line will print your coefficients, x and plus minus. All this consecutively for various terms available. And the same display can be used to have it correspondingly displayed first polynomial or second polynomial or third polynomial. Not only that, even you can think of writing it in the display that whatever first polynomial was, poly 1 written, then you write here plus, then you write here poly 2, and then you write here equal to, and then whatever result came, that could be written as a poly 3. So, of course, a slash n if you don't use, then your display poly could be used here to display first polynomial. Then display poly 2 can be used and similarly. But of course that, yeah, as long as it was a single line. If it was a double line, of course you have to manipulate and then write a special display poly which will be combining all this. So there can be a lot of improvement, lot of changes. It's just additional programming, not from data structure viewpoint, just for your practice. Then going further, taking 5 more minutes to wind up this, I'll give you another alternate. Exponent based polynomial addition can be implemented in another way. At present, we used struct. But I will say another possibility can be to use a 2D array. 2D array effectively mean that my polynomial 1 or polynomial 2, etc. will be 2D array, where I will say poly 1's index, or I will say row, first row. So I will say let it be polynomial be called as a 2D array, term 0, term 1, term 2, and I say I am going to have it first thing as one index stored or one dimension stored and coefficient another dimension stored. To be more precise, let me draw it vertically so that you get a better understanding. I say, let it be represented as this. This is index 0 and this will be index 49. But here in your column 0, I will be actually storing the exponents, and in column 1, I will be storing the coefficients. So if I say my polynomial is 3x raised to 80 plus 5x raised to 70 minus 6x raised to 60 plus 7x raised to 55 minus 3x raised square and so, I will say at 0 index, I will store 80 and 3 here. Next value, 70 and 5 here. 60 minus 6 here. 55, 7 here. X square, 2 and minus 3 here. And like this. But no structure used. So I have to implicitly use a 2D array. If you see above 1, I will declare it as now int poly 1. Poly 1 has 50 rows and 2 columns. Similarly, poly 2, poly 3. Having said that, now I will say, earlier I used word poly 1 I dot exponent. What is this equal to? This is equivalent to now saying poly 1I. Poly 1I represents the ith term or poly 1, same as this. Dot exponent, instead of this, it will become 0th column of the ith term. And poly 1I dot coefficient is equivalent to saying poly 1I with column as 1. That's it. No other change. So you don't need a structure declaration. And effectively, by this representation, you can always use exponent at one column, coefficient at second column. And a declaration will be like this. So this can be this. So I'm giving you homework. Try polynomial addition for exponent-based representation using a 2D array. And if you try modular, parameter passing will be always simplest if you do everything in the identical manner along with dimension size also. If you write precisely this, you will never face a problem. If you follow some other syntax, some other problem might come, might not come. Which one is compulsory, which one is not? There are certain answers, certain options. Once you read in C more or you read more depthfully the 2D array parameter passing, you can get an answer. But otherwise, if you write add poly like this, still this is fine. So as long as you write everything, there will be never a mistake. But you have to ensure that all parameters which are passed, they have the same dimension which you mentioned in the function definition or in the function header. 50 into 2 should be the every passed parameter, and you specify everything here. you will never get any mistake. Slowly, we will understand smarter ways of doing this also. Having said that, I think it's a time to wind up. I'll suggest everyone now to try this, and at least you should be able to do 2D array-based storage and addition. If modular, it will be good, but now probably we have to progress and aim to do modular programming also. Bye-bye, all the best. I am going to stop here now. Must try this, and those who are good programmers, the good programmers can think of doing the modular programming for 2D array also. And not only modular programming, improved display also for whatever way you could try. So good programmers must target this, but every student must do this, even if without modules. So let me wind up here. Stop.